So for this problem, it says we have a short bar with length 3.1. So we put this bar on a number line. So here 1, 2, 3, 4, like that. Okay. So let's okay. So we want to find the maximum or minimum number of integers it can cover. So let's say let's check max number of integer. Okay, so this one could be like okay, because the length is little bit more than 3, 1, 2, 3. So could it be like from this point to this point, right? So maximum number of integer it can cover is 4. So minimum number okay, so minimum number, let's say from here 1, 2, 3, like this, right? Yeah, so minimum number should be 3. Okay. So we just check this case, like here a little bit. Suppose this is the number point, a little bit left side of the number point. So how about this? Okay, so let's say 1, 2, 3. Let's say, so if bar start from here, cover from here, like 1, 2, 3, then ending here, right? So in this case still cover 4. Yeah, so this case, yeah, start from here. So 1, 2, 3. So could it be like that, right? So in this case, just cover 3. It says a checkerboard consists of 1-inch squares. So just like that, 1-inch squares, like that, right? Okay. So we have a square card. We put a square card on the checkerboard. So we want to find how many at most it can cover those area for those in square. Okay. So we have a card 1.5. Suppose like here 1.5. Like we put such a card onto this checkerboard. So smallest, what with the checker case, smallest number of square it can cover or partially cover is just like that. Let's say 1.5, like this, right? So in this case, how many square it touched? So n equal 4, right? But here we're talking about maximum. So let's check this. Let's say so this 1.5, and this longest line or diagonal, this one we find this D is 1.5 square plus 1.5 square. This is larger than 2. because 1.5 is equals to 2.25, yeah, so larger than 2. So we just put this in this way, larger than 2. So here 2. So we put this onto the this is 2. So we put the ending point here and 2 more than 2, right? So we put this card like this way. Okay. So how many square it touched? So we can say like here 1, 2. Let's see, 1, 2. So here this one, this one, this one, this one, this one, this one, right? Okay. So here's same. So we have 12. At the most, it can cover or partially cover 12 of them. 12 small square. Okay. So this problem says we have a triangle. We know two sides. This side is 6.5. That one is 10. So we have the third side is 8. So we can find what is the maximum value or smallest value of 8. So for triangle, we say, suppose this A, this B, this C. So we have this requirement: A plus B should be larger than C, right? Okay, so here we have this condition: 6.5 plus 8 should be larger than 10. So the smallest A should be like 4. Cannot be 3, can be 4, right? Okay. So for this problem, it says 1 inch squares are cut from the corners of this 5-inch square. So this is 5. So here's 1, 1. So it is like that. Okay, like that, right? So 1, 2, 3, 4, 5. So we cut this square in each corner. Then, what a question. What can be the area of square of the largest square that can fit into the remaining space? So this means that if we cut them off, then from remaining one, like we have this, right? From those remaining one, we want to make a square. So we can make many squares. The smallest square we can use this, right? We can cut from remaining part. We cut a square. So this square, this is the smallest. We can cut this square, or we can cut it big. So suppose we cut it this way. Okay, cut it. Okay. Okay. Yeah. So this square is bigger than that one. But we want to find the largest one. So let's say we just use the graph here. Okay. 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 Cut. So with the point, not the midpoint, maybe we just pick up this point here. So we want to pick this point here, maybe this, like let's say this, like this one. Okay. Yeah. Okay. Maybe like such this square is larger than that one, largest. So here we want to find what is this point. Okay. Okay. So we put this this one. So we put this as x. Okay. X is here. This from this point to here x. So this is 1. Okay. Okay. So we want to find this x. So here we use this triangle. Like, okay, so this x over 1, this x over 1 equal this ratio. Okay, so this is, let's say, so x over 1 equal 1 plus x over this. So what is this? So this equal this, right? So here we find x, that x should be like this. X over 1 equal x plus 1 over, so that's, so what is this? This is 5 minus 1 plus x. Right? Okay, so we need to find that, point. We need to find this position. So suppose this is this distance x, then x satisfies this. X over 1 equal x plus 1 over the, here's 5 or 4 minus x. Yeah, 4 minus x. Okay, so we need to find that. We need to find such x. And then if we have such this x, then the this square, the area of this square is, this, okay, so for this one, so this equals this square, right? So this square by the right triangle, so we know, we say area equal this square, and this square equal this square plus, so this square. Okay. So the problem becomes like this. The x satisfies this equation, and we need to find the value for maximum value, or we need to find this value. 1 plus x squared plus 4 minus x squared. So we find this equal, let's say, this equal 1 plus 2x plus x squared plus 16 plus 8x plus x squared. So this equal 2x squared minus 6x plus 17. Okay, so what is this number? So we just check from here. We just check. So from here we have this x times 4 minus x equal x plus 1. So this one is, so we just change this to move x, negative x squared to this side, the x squared 4 plus 4x, move 4x to this, so become minus 3x plus 1 equals 0. Right, so x satisfies this equation. Okay, so we find this equal to x squared minus 3x plus 17. and then this x squared minus 3x equal -1. So that's equal -2 plus 17. So that's equal 15. Okay, so we can stop here. Okay, so this problem is a little bit tough, right? Because we can cut a square this way, that way. So here we need to find the extreme position, extreme situation. So we can find a minimum, maximum value, like so. So those problem is also extreme problem, right? Okay, so we stop. Now we should finish this topic, extreme value.